All right, video 2, take 2. This is an example of y equals, and instead of the coefficient being 1 or -1 like we had on the parent function and then the one that flipped across the x-axis, this is a +3. And it's represented by your author as an a. So it's y equals a times x squared, where a, its value, is greater than 1, and in our case it's a 3. Anytime you have a greater than 1, the parabola, can't spell, the parabola will narrow. And the reason it's narrowing is you're having to reach 3 times as high for the y values versus the parent function. And we'll go through and make our t-chart and hopefully take note of that the values are 3 times as high. So let's use some of the same ones, -2, -1, 0, 1, 2 for our domain, or our x values, our input. And for the range, we're going to do order of operations, which says square the value, and then we're going to multiply it times a +3. So we've got +3 times all of our previous range values, which were 4, 1, 0, 1, and 4. And 3 times 4 is going to result in 12. 3 times 1 is 3. 3 times 0, I hope you guys know, is 0. Then we're back to a +3 and a +12. So this is our new range. These numbers are 3 times what the previous range values were. 3 times 4, 3 times 1, 3 times 0. So let's see what these are going to look like sketched. I don't know if I have a y-axis tall enough, but go for it anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So -2, 12, -1, +3, 0, 0, which is the vertex, it's the dip, over 1, up 3, and over 2, up 12. So I don't know if you've noticed what this looks like compared to the parent function. This is y equals 3x squared. If you remember, the parent function was 0, 0, -1, 1, 2, 4, 1, 1, and 2, 4. So -2, 4, +2, 4. So it kind of did this. Nice U, not a V. And so what's happening is you're having to reach 3 times as high for these values, and as you're having to reach higher for the values, the parabola is narrowing or closing in. All right, let's see what the next one's going to do. Moving our camera down. Kind of got a ghetto stand here, but I think it's working. All right. Let's choose again -2, -1, 0, 1, 2. And notice what our A is this time. Our A is a value of 1/3. A, in this case, is less than 1. And when A falls into a value that is less than 1 but greater than 0, it's a fractional value, and the parabola will widen. It'll get wider. It'll spread out. So let's see what's going to happen. Now again, all our earlier values are going to be multiplied by 1/3. So our earlier range values were, from the parent function, 4, 1, 0, 1, 4. So this time I've got 4/3, 4 over 1 times 1/3. 1 times a third. 0 times a third is 0. Again, 1 times a third and 4 times a third, which is 4/3. So practice up on your fractions if you have to. Okay. -2 to +2. We're not going up very far on the y values because 4/3 is the same as 1 and 1/3. Same as 1 and 1/3. So for -2, we're going up 1 1/3. For -1, we're only going up 1/3, just above the x-axis. We've got the origin or the vertex, 0, 0. +1 and 1/3, and then +2, 4/3, or 1 and 1/3. And you'll notice that the parabola is really widened or fattened out. So we've got a narrowing of the parabola, a widening of the parabola. And I've got another, what's called a translation, if you will, of the function. Get our camera tilted. All right. So this top example is just y equals x. And if you remember from the earlier chapters, that is the identity function. It is linear, okay? This y equals x plus 4, same slope, which is a 1/1, but the only difference is it has a y-intercept of 4. So this is y equals x. This is y equals x plus 4. It does a horizontal lift or shift up 4 units. And the same thing is going to happen with the quadratic. I'm just going to sketch it in because my camera's running out of time. This is y equals x squared. If we do a y equals x squared plus 4, all the values are going to be raised 4 units. If it's a y equals x squared minus 4, it's going to drop 4, but still be pointed in the upward direction as long as it is a positive x squared. All right, that's all I got for now. Thanks.